Okay, the question 1 asks us to sketch the free body diagram of the object. So this is the free body diagram. The height 3.5 meter has been given in the question. So this is the object or the ball that we use, and this is the VB acting towards here. This is the Y node, and this is the force. So we calculate the average of X node, Y node, and theta. So we calculate the average of X node. The value is 0 plus 0 plus 0 is taken from the graphical analysis that we get from the tracker software. So we add 0 plus 0 plus 0 over 3, and the answer is 0. And for Y node, the value that we get from the tracker software is 0. And in the question asks us to assume if Y node equal to 0, then Y node is equal to 1. So we use 1 plus 1 plus 1 over 3, and the answer is 1. And for the theta, 63.1 plus 46.2 plus 30.6 is we get from the graphic from the experiment too. We add 3 of the values and we divide over 3, and the answer is 46.63 degree. So this is the answer for the question 1. And for the question B, we need to calculate the speed of the object just before it leaves the surface at B. So this is the formula for this question. T1 plus summation of U equal to T2. And formula for T1 is 1 over 2 M bracket VA square. So this is the formula for T1. And MGH is the formula for the summation of U, equal to 1 over 2 M bracket VB square is the formula for T2. So we eliminate M because we don't have the values of mass of the ball, because the software tracker we cannot put the mass there, so we eliminate the values of M. So VA is 0 because at the initial of the throwing, the velocity is 0. So VA is 0. 1 over 2 times 0 square plus 9.81 is for G, the gravitational force, and 3.5 minus 1 is for H, equal to 1 over 2 VB square. This is for T2. So after the calculation, we get the answer VB is equal to 7.004 millisecond.
Okay, in this question, we use kinematic relation in X and Y direction. First, for X direction, we use equation for horizontal motion. Then we will get the first equation. While for Y direction, we use equation for vertical motion. As we calculate, the value for TBC is 0.4515 seconds. Then we substitute the value 2 into equation 1. After substitute, then we will get the value of D. Okay, for the D question, to get the compute speed which the object hit the ground, we can use principle of work and energy between A and C. We can simplify the summation TA and summation TC in 1 over 2 mass times velocity A and squared, and 1 over 2 mass times velocity C squared. VA is equal to 0 because the object in static condition. Then we calculate to get the value of VC, equal to 8.2867 meter per second.
Question 2a. In this FBD, the object is released from rest at point A. Then the object is slipped down due to the gravity. It passed through point B and fall to the point C with velocity from B. and bounce to point D with velocity from C. The height of y0 is 1 meter, so the height from A to B is 2.5 meter. To analyze the question A, due to the object is released from rest at the beginning, then use formula principle of work energy as I showed in question 1b. Okay, so we can get the initial velocity, which is velocity of B equal to 7.004 meter second. So we can consider VB is the velocity before rebounds at point C, at this point V1. Okay. By considering the vertical motion of the falling object, we need to use this formula to find the velocity at C, at y-axis, which is VCy is equal to negative 4.43 meter per second. From this equation, value coefficient of restitution 0.7 as the given from the question. Apply the coefficient of restitution in y direction to determine the velocity of object after it rebounds from the ground. Therefore, the rebounding velocity of the object C is Vcy equal to 7I plus 3.101 J meter per second in vector direction. Since the equation, we can get the magnitude is 7.66 meter per second. For question B asks to find the height of H, so we can use kinematic equation, which is vertical motion of the object after it rebounds from the ground. Use this equation. From the calculation, we get the height of H is 0.49 meter. That's all from us. Thank you.